First of all, welcome to Xamarin Dev Days at Syncfusion. Oh, this is really loud. Sorry. Great, thank you. I'm Marisa from Syncfusion. I just had a few quick notes for you. First of all, I wanted to introduce you to all the Syncfusion staffers. So if you guys would raise your hands, everyone in the blue or orange shirts. If you have questions about Wi-Fi, Dylan is your guy. Dylan, could you raise your hand? He'll be here this morning. Every attendee, as you probably already know, is going to get a free license to our Essential Studio for Xamarin. That's over 90 controls for Xamarin. It's over $1,000 value. Yeah, exactly, right? So that's super cool. What else do we have here? Oh yeah, at lunchtime, if you'd like to share your experiences today, we'll be doing video interviews with our colleague Stefan. He'll be arriving right about lunchtime, and he'll be in the lobby area. So if you do that, that would be really great. We did it last year as well, and it was really fun. And that's all the very quick updates. I want to go ahead and get started. Our presenters today are Syncfusion's very own Aaron Melamed. He'll be starting us off this morning. Then we have Xamarin MVP Ed Snider and Dan Rigby, a Xamarin consultant at Microsoft. So have a great morning and a great day. Thank you for coming.
All right, thank you, Marisa. So, good morning, everyone.
Good morning.
All right, so let me hide some windows here. So, welcome to Xamarin Dev Days at Syncfusion. First of all, I just want to thank you all for being here. Hopefully everyone had an easy time finding the office this morning. All right, let's get right into it. So you guys already saw that you've gotten a free license for Essential Studio, for Essential Xamarin Studio from Syncfusion. So if you don't have one of those cards, just let one of us blue shirts know, and we'll make sure you get one. So on today's agenda, we're going to have three presenters, as Marisa mentioned, starting with myself. I'll be doing the introduction to Xamarin, which will include a very quick dive into Visual Studio just so you can get a feel for creating a native application in Xamarin. So I'll explain what it is, what you need to get started, and again, what it looks like to develop in Xamarin. So next up, we'll have Ed Snider, who will talk about building a cross-platform application, or cross-platform UI rather, with Xamarin.Forms. And then we'll have Dan Rigby, who will go over building connected apps with Azure. After that, we'll break for lunch, and then we'll close up with a new app workshop where you'll be able to download our lab and follow along as we build an app from scratch. So everything that we're going to show to you today is already available on GitHub. So there's the link on the screen right now. So github.com/Xamarin/devdayslabs. We've also got some USB keys, I think, floating around somewhere if you wanted to plug that in and get the download from there. So I'm going to be starting things off today by talking about creating a native iOS and Android application in C# using Xamarin. The goal with this section is to give you essentially a complete 101 overview of what it's like to get started with Xamarin. So we're going to be answering questions like how does it work, why would you want to use it, and how you can leverage your existing Windows applications by bringing over your existing C# code base. And lastly, we'll also take a look at some of the extensions and plugins that are available for Xamarin. So typically in these presentations, we have this slide where the presenter introduces himself. So I am Aaron Melamed. I'm the product solution specialist here at Syncfusion. So I handle things like overviews with client relations and sales teams. I do webinars, presentations like this. I'm also on the consulting team where I facilitate discovery calls. And sometimes I also handle support issues. One thing I am not is a developer. So at least not yet. I've actually started to study C# and .NET. I've been studying C# and .NET for about the past year. So I'm actually really excited to be here, not necessarily to present, but actually to merge into the audience and listen to the rest of the presentations after my section. So usually if you've seen presentations like this, because the presenter usually is a developer, there'll be links to follow them on Facebook, Twitter, their blogs, et cetera, et cetera. I don't do any of that. If you really want to, you can find me on Facebook or LinkedIn. But I did one time use a Snapchat filter, so there you go. So let's get into it. So when you think about architecting an app, there's a few different ways you can go about doing that. In general, you'll probably want to create a native application because you want the best performance, and you want access to each device's native APIs. So the old approach is the siloed approach. So this means if you want to target all of the major platforms, you need to create 3 different applications, one for iOS, one for Android, one for Windows. And yes, I did just refer to Windows as a major mobile platform. So that also means you need to know Objective-C, Swift, and Java. And you need to work with Xcode and Android Studio. And that's in addition to C# and Visual Studio, again, if you're targeting Windows. So that's at least 3 different languages, 3 different IDEs, on at least 2 different operating systems, with nothing shared amongst them except for maybe some basic assets like your logo or something like that. So while this approach obviously gives you native applications, so it gives you direct access to everything you need to create the best performing application, it just leads to a very expensive overall development environment. And so what about write once, run anywhere approach? So a lot of developers typically think of this when they think about mobile app development. So this essentially just gives you a bunch of code that you shove into a magic box, and it gives you mobile applications. So there are many different frameworks that do this with varying results. Some get closer to a native-like experience than others, but ultimately all you have is a glorified web application that doesn't give you access to all of the native APIs for whatever platforms you're targeting. And so that's where Xamarin is different. So Xamarin delivers a true native application for iOS, Android, and Windows from a shared C# code base. All of your business logic would live there, so all of your models, views, RESTful service calls, SQL databases, etc. All of that would be there in a single code base shared amongst all of those platforms. So from there, on top of that, you can build your native UIs for iOS, Android, and Windows, all in C# with full access to all of those platforms' native APIs. So let's look at what this actually looks like. You have all of your .NET APIs, things like System.io, Link, Numerics, Core, etc. This is just a subset of .NET, of course, but normally this all runs on a Windows machine. And so, but it can also be, of course, on mobile devices like tablets and phones with UWP or even ASP.NET, an ASP.NET website. But in order to target those platforms, you need to download an SDK that would give you access to all of those APIs. So now you can think of Xamarin kind of in the same way. So on top of that, you'll have your, for example, iOS APIs. So Xamarin brings all of .NET and everything you already know and love about iOS and Android over to .NET. So it's support for .NET that really sets Xamarin apart from any other cross-platform application tool. So on iOS, you have access to things like MapKit, UIKit, iBeacon, Core Graphics, everything else iOS has to offer. And the same thing for Android. You get 100% coverage for all of Android's APIs, so you have the same experience across the board, essentially. So this is all done through powerful C# bindings around every single API. So that gives you C# features like async await, lambdas, events, delegates, and more. So again, everything you already know and love about being a .NET developer is going to be here part of Xamarin. All right, so let's talk about building user interfaces. So there are 2 ways to build a user interface in Xamarin. The traditional approach is where you create a native user interface on top of your C# shared logic. So this is the approach that I'm going to be actually demonstrating a little bit later in this presentation. And this just basically means that you create, you actually need to know a little bit about how iOS and Android development works, so you can actually build a native UI on top of your shared logic. Then the second approach is Xamarin.Forms. And so that actually introduces a shared UI code layer, and it gives you an abstraction of all the common UI elements. So this naturally doesn't give you access to absolutely everything that you can do natively in either platform, but it provides access to all of the common elements. And again, Ed is going to be talking about this more in detail in his section. So as I mentioned before, these are all native applications at the end of the day. So there's no web browser running everything unless you really want there to be. Of course, you have the freedom to do that. So on iOS for Xamarin, there's a full, it does a full ahead of time compilation to produce an ARM binary. While on Android, Xamarin takes advantage of just-in-time compilation. Xamarin is also always up to date. So they've had same-day support since iOS 5, including all the dot releases. For Android, they have support for all the APIs, including Marshmallow, NuGet, and they're currently working on Android O. So this also includes support for virtually all mobile devices. So anything that can run an iOS or Android application is also supported via Xamarin using C#. So that means you can have C# and .NET on your TV, on your wrist, your glasses, your AR toilet, whatever it might be.
Sir,
Yes.
what about Amazon Fire Stick or stuff like that? Amazon Fire, because it's Android based.
Yeah, so that is supported. I don't know if there are any built-in templates for that. There are templates, and I'll show this in a little bit. There are templates for things like Android TVs, Apple Watch, Android Wear, things like that. I'm not sure if we have templates for Amazon Fire Stick or TV, but should be supported if it's Android-based.
All right, great.
Yeah. So truly anything that you can do in Objective-C, Swift, or Java can be done in C# with Xamarin. So at this point, let's talk about building an app. So before I jump right into Visual Studio, I do want to cover a few things, starting with the development experience. So first of all, main question is, how do you actually get Xamarin? So hopefully all of you guys have Visual Studio installed, and if you don't, well, you should probably do that. But Xamarin is included in Visual Studio. So it's included in all editions, including Community Edition, so it is a free download for Visual Studio. Even better, Xamarin is open source. So if you go to open.xamarin.com, you can actually learn all about their open source initiatives, and all of the components are open source, including Xamarin.Forms. Now, when it comes to actually installing the Xamarin components inside of Visual Studio, if you're using Visual Studio 2017, you'll have access to the Visual Studio installer, and you'll want to make sure you check the box for mobile development with .NET. That'll give you everything you need for Xamarin. And so as part of that installation, it'll automatically install everything you need to get started, of course, with Xamarin, but it'll also include things like all the Android SDKs, at least all the latest ones, as well as all the latest emulators, which we'll get into in a little bit. Huh. I think it stopped working. There we go. So, for Android and, of course, Windows development, you can just use a PC for anything you want to do. So that includes running Android and Windows device emulators, of course, deploying directly to your devices. But when it comes to iOS development, as you might imagine, there are a few caveats. So I noticed that some of you have Macs in the room, so you might be aware of this already. But you can actually, when it comes to editing code for iOS, you can actually do that just fine on a Windows machine and just a Windows machine. But when it comes time to use things like the designer, or if you actually want to compile and build your code, you're going to need a physical Mac device. You're going to need an actual Mac device to do that. And so, Xamarin for Visual Studio connects, or provides a couple ways to kind of handle that. So it connects to, it provides ways to connect to a Mac device so that you can still do everything inside of the Windows environment, Visual Studio inside of Windows, but it'll just send over all the compilation work, all the build work over to a Mac, and then it'll send the results back to Visual Studio on Windows, essentially. That's one way you can handle it, is by having two machines and kind of remoting into your Mac from your Windows machine, or these panels. Or you can just download Visual Studio for Mac. So hopefully you guys are aware that Visual Studio is now available for Mac. It is specifically geared towards mobile development. So it's basically a Xamarin Studio, really. So this includes, so the Mac version allows you to create apps for Android, iOS, and macOS using .NET. It also includes tools for Azure, Unity game development, and more. But most importantly, it actually allows for a more streamlined mobile app development environment, since you can run your iOS and Android applications on just one machine. So there's kind of an advantage to using that approach.
Question?
Yes?
Does the Visual Studio for Mac include a Windows device emulator?
It does not. At least to my knowledge, it does not. I haven't seen it on my machine. The default installation does not. So it'll actually give you some access to your, for example, I have a UWP application in one of the projects I installed on it, or loaded up on it. It'll give you access to the code, but it just won't let you do anything with it. So you would still need, I guess, parallels or something like that to.
Yeah, I use VirtualBox.
Yeah. Yeah. So there's another kind of option here when it comes to Visual Studio and iOS compatibility. So on Windows and Visual Studio, there is now an iOS simulator, the capability to remote into the iOS simulator. So if you have Visual Studio Enterprise, you'll have access to this. If you have Professional or Community Edition, you'll be stuck with having to do everything on your actual Mac device for when it comes to interacting with iOS. But the iOS simulator for Windows is actually really cool. If you have a touch device like a Surface or any other touch-enabled device, you can actually use your finger to interact with that iOS simulator. It's really fast, and obviously you don't ever have to leave Visual Studio to run your iOS code.
Excuse me.
Yes.
I have problems with getting that to work. It works on it launches it on the Mac every time, even though I do the checkbox.
Mm-hmm.
So is this something that requires some kind of like beta or whatever tools? Or does this work for you, I guess is the question.
I don't have Visual Studio Enterprise, unfortunately.
Oh,
I just
okay.
have Professional, so I've never actually tried it.
It does not require data. It's in stable channel. If you're having trouble with it, I would actually reach out to support. That should actually.
It should work.
It should work.
Okay.
Yeah, sorry about that.
So does that then replace the build and targeting of the iOS simulator on a native Mac if I were using my Windows VM?
It does not, because it's basically running the simulator on the Mac headlessly and then remoting the interface over the Windows.
Okay.
Just so you can interact with it. Now the nice thing there is if you have a Windows machine that has a touch input screen, it does multi-touch like a Surface, you can actually do touch gestures through the simulator remote.
Yeah, thank you. Okay, so I think that was supposed to be my transition into Visual Studio, so let's go ahead and do that. So, wrong screen. What I will do now is actually duplicate my screens so that you can actually see what I'm doing. Okay. So here we are in Visual Studio 2017. And is there a way to hide this? No. There we go. And before I actually get into the project we have loaded here, I'm actually going to show you real quick what it looks like to start a new project, some of the options that you get, some of those project templates. So if you do have the Xamarin components installed in Visual Studio, when you come to your new project window, you'll have this cross-platform folder. And if you check that under the Visual C# section, you'll see that you have access to cross-platform apps with Xamarin or class libraries with Xamarin.Forms. When you choose a cross-platform application here with Xamarin, I'm just going to call this test. Then in the next step, what kind of Xamarin application do you want to create? So do you want just a blank app? Do you want to start off with a master detail template? Do you want to use Xamarin.Forms, or do you want to stick with native UI? And then, of course, what's your code sharing strategy? Do you want a shared project, or do you want a PCL, a portable class library? For the example that I'm about to show you, we're going to be using native UI with a portable class library. Let's cancel that. And I guess I have to reload my project. Okay. So there's a couple things that are kind of going on here with my setup. So you'll notice I do actually have two machines, a Surface Book and a MacBook Pro. I'm doing that because, as you can see here, we have three different projects in this solution. We have an iOS project, we have an Android project, and the third one, the portable, is, of course, our portable class library. So for me to be able to actually do anything with the iOS project, I need to be remoted into this Mac. Xamarin provides all the tools you need for that. There's actually controls for it here. When you first start it up, if you haven't gone through this already, you'll be walked through this process. And so essentially it'll tell you what you need to do on your Mac machine in order to enable remoting and all that, and also what you need to install on your Mac machine in order to set this up as a build agent. So as you can see, I'm already connected to my machine, so I'm kind of ready to go there. What I'm actually going to start off by showing here is the portable class library. So this is actually a pretty simple application. It's a simple one-page application. All it does is it uses Bing search to, or the cognitive services of Bing search to pull back images. So as you can see here, this was designed using the MVVM design pattern. So we got view models, services, models, etc. So if we start by looking at our services, you can see here we have a Bing search folder. Inside of that, we have all the various models for all the data that's returned from there. So we have our image model here. So this is using JSON.net. So you can see here already off the bat, we're using standard stuff. Nothing magical or special or Xamarin specific here. We're using all our, we've got all JSON properties defined here so that whenever we do our deserialization later, everything maps accordingly. So that's our Bing search folder under services. We've got our service keys for the API that we'll be using. Then under the model folder, we have this image result model. This is just a simplified version of all the results that we're getting from Bing. So this is basically all that we need for the purposes of this particular app. We just need a thumbnail link, an image link, and basically really a title. So that will just simplify the API for that. Now, if we look at the view model, that will, of course, be kind of the meat and potatoes of this application. So can you guys see that all right? I should probably zoom in. That's probably better. Too big? Perfect or too big?
It works just
Okay.
fine.
All right. Let me...
Let's hope folks know help we can get.
All right. So right off the bat, again, right on the top here, you can see our using statements. There's really nothing special here. We're using LINQ. We're using .NET. We've got our .NET HTTP, JSON.NET, of course, our using statements for our models, things like that. Now, there are a couple of other plugins or other packages here that we'll talk about later, like ACR user dialogues and plugin.connectivity. But for now, just the point is, this is all standard stuff. So let's see if I can find my place here. So if we come down to line 37, just kind of right off the bat, here you can see where we're actually building out our query for the Bing search cognitive services. So there's the URL. Here's the search query itself. So we're actually using some C#6 string interpolation here for this. And then you can see we're pulling out just the first 20 results from the images. And so once we create all that, so we set up some request header keys which will feed it the API keys in order for this to actually work. You can see coming down, we've created a simple HTTP client. So again, nothing new or spectacular here. Standard HTTP client. We're using the await command, so we're getting our string asynchronously. We're then deserializing that result into the original or the default search result from Bing. And then we're going to take that, so that's here on line 51, by the way. And then we're going to take that, and then in this block here, we're converting those results into our image result that I showed you earlier in the more simplified model. So we're just pulling out the image URL, the content URL, the thumbnail URL, the image URL, as well as the title for the image. And that's pretty much it. That's all that's in this view model. Aside from that, we do have that user dialogues, an instance of user dialogues that will just pop up an error message if that client fails to connect. And so this is it. So this is all that we need for our shared code. And from here, we can actually move into the native stuff, the native UI. So we're actually going to start with Android. And before I actually show you some of the Android code, I'm actually going to just deploy this or build this so you can actually see what it looks like. So I've actually preloaded the Android simulator here just because it takes a while to load up. So hopefully this will work now that it's live. It worked about an hour ago. All right, I'll just let that run in the background. So we're going to start by looking at some of the references we have here in this Android project. So if I make this bigger, if you look at the references, you'll see that, again, we have basically everything that we were using in our portable class library. So everything that was there is being used here in the Android project as well, in addition to, of course, a reference to that PCL. And then anything specific to Androids like Mono Android, and then some Xamarin specific stuff like all the Xamarin Android packages that are required for this to work. You don't really need to worry about those. Those are automatically set up for you whenever you create a new project. Everything else, though, whenever you create your PCL, you'll be able to add your additional references. So here's what the actual application looks like, what it does. So if I type in car, do it on the screen. So if we type in car, it'll go out using Bing and return some images eventually. Yeah, ooh and ah. So, so pretty simple. So now if we go in here, let's start by looking at so when it comes to Android, there are a couple things that, if you're not familiar with it, you need to be aware of. So you have an assets folder and you have a resources folder. The assets folder is not the same thing as you'd find in, for example, UWP development, where all of your images and things would go there. That's where you have kind of like document resources and things like that. Inside your resources folder, you would have things like your drawables, which those are going to be your icons, your app icons, your logos, splash screens, things like that. Also inside of the resources folder, you're going to have the actual pages that make up the application. Those will be found in the layout folder. So you can see here we have 3 different Android XML files. The one called main is going to, of course, be the main page of this application. And so if I open up this main page, you'll see that it automatically starts to load the Android designer. So I'll give that a second.
Got a question while it's doing that?
Yeah,
So when you're running Visual Studio on the Mac, can you do all the same stuff?
most of it. So actually, I forgot to remote into this Mac.
iOS apps, Android apps, and Azure scenarios. Those are the main ones covered by Visual Studio for Mac today. So Azure services and for apps as well. So IESP.NET.
Yep. Yeah, and I'll actually pull up Visual Studio on the Mac so you can see it. Okay, so now that we've got the designer pulled up, you can see you can do things like change the theme. So if you wanted to change it from that default theme, you can use a light one, for example, like this. You can also, of course, change your device type if you want to simulate different devices. And more importantly, you still have access to your toolbox. At least you should. Never mind. That should show all the Android controls. It was working earlier. So typically what you would see there is all of the Android controls you'd expect. So buttons, search boxes, text boxes, labels, whatever. All that stuff would be there inside of this once you pull up the designer. But you also, of course, still have access to the source of these pages. So if you look at this, this is the Android XML. And one thing to note out of the box is that Android and iOS out of the box don't have an MVVM type framework. So there are some libraries that will kind of add that in there that you can use with this. But then also there's Xamarin.Forms, which again we'll be talking about a little bit later, which does have that built in. So just kind of keep that in mind. And so inside of this Android XML, here we have all the different elements you just saw on that page. So we have our toolbar, we have the actual search bar, the edit text bar, progress bar, which we'll be using once we actually hit search, and of course the button itself. And then down here we have this recycler view, which is what's going to actually contain the images once they're loaded in from our services. So let's go back into, so kind of just like you would expect, there's also code behind with all of these pages. And in Android, those are actually called activities. So we only have one page, so this one is called main activity. So let me get rid of this. There we go. So this is the main activity or the code behind for that page. So you can see here right off the bat, again, we have all of our using statements, all the standard stuff. We're automatically using all the Android packages that we need for this to work. You can see here we're declaring some variables. So we've got a recycler view, layout manager, and adapter. This image adapter I'll talk about a little bit later. This is what actually gets those images to load into that recycler view. And then we have, of course, a progress bar. Then here on line 21, we have our reference to our view model, which is coming from that shared portable class library. So moving down, we can see here that we've created a new instance of that view model. Then we're creating instances of we're actually using this find view by ID method to get access to those elements that I mentioned earlier that are on the page, that recycler view, the grid layout manager, the progress bar, etc. So once you do that, so there's a couple ways you can do that. So there's some, or rather, let me backtrack. There's some interesting things that happen when you do that. So if I, for example, come up here and, I'm debugging. If I come up here and create a new button, for example, and I'll just call it button. I can come down underneath the actual button we've already called. I'll look at my button, and when I hit button dot, you'll see that I actually have access to all of its properties. So I have access to, for example, its click event. So using standard C# code, we can add a simple click handler to do whatever it is that we want. So I'm not going to finish that out because it's already been done with this click button here. So you can see that we've found that by using the find view by ID, we pass on the type of button, and then we find the resource ID, which is in this case the name of that button, my button. Once we get all that, then we can again create a click handler or assign a click handler. And what we're doing here is pretty simple. When someone clicks the button, we disable the button, we turn on the progress bar, we do our search for images method, or we call the search for images method here, which is awaitable. And then once that comes back, we turn off the progress bar and turn the button back on. And again, that's pretty much it. So if anything else happens, then we pull up, we throw out some user dialogues, which will give some sort of error message. And that's really all that's necessary to get this to work. So it's just a one button, one page application. And as I mentioned, we are using a image adapter to actually display those images. So let's quickly take a look at that. So here, what's going on is we're essentially taking the results of the Bing search, and we're using, in this case, we're using the Picasso library to actually load those images, and then we're assigning the caption value to that recycler view so that we have our image with the caption underneath it. And again, that's really all that's going on here. So now let's look at the iOS version, because this one is actually a bit more interesting just because there are a couple of, as I mentioned, a couple of differences in how iOS development is handled. But actually, before I do that, there's one thing I wanted to point out. So if any of you guys have not done Android development before, you can, of course, if you see here, we have access to various simulators for Android. There is an SDK manager that allows you to download additional APIs, which can come with additional simulators for older devices or newer devices. You can, of course, plug in your physical device, and it works basically right out of the box. You just have to enable developer options on your device and turn on USB debugging. And then you also have the ability to connect wirelessly to your device. So using the ADB command shell here, you can wirelessly connect to your device, which I probably shouldn't try live, but let's see if it'll work. All you need to do, if you've never done this before, all you really need is the IP address of your device on your Wi-Fi network.
Have you done anything with UI tests?
I haven't, unfortunately. So, all right, so let's try this out. So, ADB connect, and 172.16.105. Let's try it. And there we go, it's connected. So you can see that right away, it found my phone, Galaxy S8. And the reason I point this out is because if you are using something like a Surface Book or any of these newer Ultrabook devices, you probably only have one USB port, or maybe none, depending on your scenario. So if you use wireless debugging, you can connect multiple devices without actually having to use up your precious USB ports. So this works just like it would as if the device was physically plugged in. You can set breakpoints, and it will let you step through your code and all that. So it's actually pretty fast. So that's that. So now let's load our iOS project. Let's close that. All right. So again, starting with the references, everything is here that was there before. There are some minor differences for our iOS specific packages. Really, it's just this one down here, Xamarin.iOS. So there's a resources folder that contains things like our iTunes artwork. So that's going to be your application logo. It's also going to contain your launch screen. You'll notice that we have these storyboard files. So Android has that concept of different screens are different pages, so they're different files, whereas iOS is the concept of storyboarding, where you can have a single file that essentially defines your entire UI. And so if I come down here to our main storyboard and open that up, this is where you first need to have Visual Studio connected to a Mac. This right here is the iOS designer. This does not work unless you're remoted into a Mac machine. So without Mac machine, all you can do is, you'll actually, nothing will happen. You don't even get an error message, really. So once you're here, hopefully this one will work. It's kind of the same story that we had before with iOS. So you can view this as a generic device, or you can view it as a specific device if you want to target, an iPhone 6 Plus, if you want to target that 1080p resolution, or whatever non-HD resolution the smaller ones are. So you also, if this works, there we go, still have access to all the controls in the toolbar. So you can still drag things on there, like if you wanted a new button or a new slider, all that works as you would expect. And then there's also properties here, so you can use the properties window to set those controls up. But of course, there's code behind, and that's what we're going to be looking at. So I'm going to delete that if I can. So one thing I want to point out before I look at the code behind, if I select the page itself and go back to that, so the page itself is assigned a class of view controller. So each page, if you will, in iOS is essentially a view controller. And so as such, our view controller file here is the code behind for that page. So again, this is all still C#. This is not Objective-C or Swift. Let's see. Okay, so inside of this we have our lifecycle events, just like we would in other platforms. So here we have our view did load. So this is essentially your initial lifecycle event, and then from here we start assigning. For example, we create a new instance of our view model, again from that shared code base, the PCL. We are then using a collection of view images, so that's going to be what's holding all of our image results. And then we do the same thing we did before in Android. We have our button, and in iOS, the click event is called touch up inside. So we assign that a click handler, and we do the same thing we did before. So we turn the button off, we turn on the progress animation, which is here, just called an animation, or activity is loading animation. We do the get, or the async, we run the async query for our images, and then because we're using a collection view, we have to manually refresh it, so we have to tell it that there's new data there, so we have to run this reload data method, and then we can undo everything we did, so we can re-enable the button and then stop the animation. So this is a bit simpler than what we saw in the Android example, because we don't have to do we don't have to use an image adapter essentially to load the images. Here we just are populating our view cell with the results of that string. So once we run that, then we can populate our view cell with the collection view that we've created. And so to get this to show you guys what this looks like in iOS, I am going to build this on my Mac. So let's hope this works. So when you set your startup project as iOS, you get, of course, your options of device or simulators. When you do a device, you need to, so in order to deploy to a device, you need to be a registered Apple developer and enrolled in the Apple Developer Program, which is kind of a little bit of a hassle and a little bit convoluted, and it's also not free. So if you haven't done any of that, your only option is going to be to use a simulator. So if I choose any one of these, hopefully this will go off into my Mac and build this out. So while that's working, I'm going to try and connect to that machine.
Yeah, also just an FYI, Apple has recently relaxed their standards where you can sideload your own personal device.
Right, yes, there's a good point. And you can create a temporary certificate, and it lasts about a week,
It's
right?
a bit of a pain in the ass,
Yeah.
but it's nice to be able to do.
Yeah, so there is that option. But yeah, so you can't necessarily deploy to your own devices without asking Apple for permission.
Yeah.
Okay. So I've just remoted into the Mac machine that's sitting right here next to me, so you can see what's going on with the screen there. It automatically loads the iOS simulator. Even though I am running Visual Studio in the background, it's not necessary. This all happens automatically. As long as you have the Mac build agent installed on the machine, this will all just happen automatically. But as you can see, in order to actually see my iOS project, I have to use this Mac machine. So here's the same application. It works the same way. Now, one thing that I do want to show here that is common across the board with our native applications here is that you also get access to, let's go here. So one thing I want to point out, so just watch what happens when we do a search. And also by default with the iOS simulator, you can just use your keyboard because obviously there are no Mac OS touch devices. So if I search for a car, for example, it kind of works the same way it did on Android, where the image just kind of pop into place. There's no pretty animation, let's say. So I can add one though very easily, and I can actually access all of the native animations inside of iOS. So what I'm going to do is once we click the button, we're going to add, let me stop debugging. We're going to add an animation here. So we have an awaitable animation. So Android or UI view dot animate layer or animate async. So one thing that is really key here is that iOS does not have any asynchronous animations, but with Xamarin we do actually have those. So you can see here we have animate and then we have animate async, which you probably would have guessed since I did use the await keyword. So I can use that to then, for example, over half a second, and yes, I am following a script here. Over half a second, I'm going to essentially fade out our collection there. If I can type. So set that to 0. And then I will just reverse that after our data loads. Set that to 1. So now I'll build this again on iOS.
So that UI view class,
That's a native iOS class. So even though Syncfusion is sponsoring all this, we're really not kind of pushing ourselves here. So I'm just talking about everything that comes with Xamarin. So yeah.
I was wondering if you were going to be going over some of the Syncfusion steps.
I can, and we can. We'll definitely have time for that, but for this part, I'm just sticking with Xamarin for now. All right, so if we do search now, you notice that it does a nice fade in. So those are the kind of things that you can do with Xamarin. And so now that I have a collection already on the screen, you can see that it will fade out as well. So again, if I do my car search, it will fade out and then fade back in once those images actually have been returned.
So a question while that's going on?
Yeah.
So there's different ways to generate UI. A lot of times you can do it in code, or sometimes you can use a designer.
Yeah.
If you use the designer, then you're going to be using a lot more Android, XML, or iOS, whatever the GUI builder is.
Yeah.
So how much percentage do you think of your UIs do you actually do in code versus using the designers from the tools?
It depends on how deep you want to go into it. Like you see here, when you want to do animations, you want to dig into the code behind. You can only set your. Sorry, I should mute this. You can only set your basic properties from the designer, but you then have to go into your code behind to actually set them up. And maybe Ed or Dan can probably provide a better
I've
answer
seen
than
people
that.
try to do everything in code behind, but a lot of times that if you have a really complex UI, that seems like a really hard thing to do.
It is, yeah, it certainly is, and actually it'll be one of the things that might be covered on Xamarin.Forms, because when you use Xamarin.Forms, you can do everything in XAML, or you can do everything in your, neat.
That's why it was taking so long.
Yeah, good old Bing. Let's just try monkey, since it seems to like monkeys. There we go. Apparently monkeys is the way to go. So. So yeah, when you go into Xamarin.Forms, you can use XAML to do your UIs, or you can do everything in C#, just doing it that way. So you have a lot of options of how you can do it. It's just your preference. So yeah, so that is that. So let me switch back to the slide deck, and then I will wrap up my section.
I have a question.
Yeah.
And that be related to what he was asking. How much of this is shared between iOS and Android? It looks like you had like two little apps, right?
Right. So everything that does, in this case, the searching for the images and loading them up, that's all shared code. What I'm showing here is the native UI approach. So everything UI related, you have to write for each platform. So there.
So UI is unique to the platform, but
Yes.
the actual search itself was common.
Correct. So if we look at the portable class library here in the view model, this is the actual search that's being performed. And this is shared with both projects. And so again, when Ed comes up and talks about Xamarin.Forms, there will be a shared UI as well on top of it. So you don't actually necessarily have to do that. And that shared UI would be across iOS, Android, and Windows. Okay. So
Just kind of jumping ahead a little bit.
Yeah.
So the Syncfusion Essential Studio, that is mainly geared towards Xamarin.Forms for your shared UI, correct?
we have a Xamarin.Forms version, and we have separate controls for Xamarin Android and Xamarin iOS.
Oh, okay.
So we do have all that, and I believe the Essential Studio that you guys are getting gives you access to all three.
Oh, nice. Okay.
Yeah. So let's extend. There we go.
Given the level of complexity of keeping track of both environments, wouldn't it just be safer nowadays to just use forms and just not worry about it?
That's what I did when I decided to dive into this. I stuck with Xamarin.Forms because I didn't want to learn, Android and iOS on top of C# and .NET. All right. So for the end of the presentation, I just want to talk a little bit about how Xamarin has simplified development in general. So again, when we think of development for Xamarin, you think about the shared C# backend, or at least I hope you do now if you didn't understand or didn't know what Xamarin really was before. But what about everything else? What about all the core Android, iOS, and Windows APIs? So what about that stuff that lives on top of that shared code base? So there are a lot of there's a lot of platform-specific code for very common things like accessing your battery, your GPS, your lights, your notification, all those APIs. They're common across all the platforms, but they have very different ways of accessing those things. So what if you could access those native APIs from shared code? And what if you just want to say, take photo, check connectivity, or get location inside your portable class library so you don't have to do that 3 times or however many times in your UI? Well, you don't have to. So, guess I didn't do that right. So you can actually do that. You can actually, for example, say, if you wanted to use text-to-speech, you could just simply say, speak, hello world, and then all 3 projects will do what they need to do. So you'll be able to use AV speech synthesizer in iOS, text-to-speech on Android, or speech synthesizer on Windows using one line of code. And so Xamarin has created a common API. And so you can actually see, if you go to Xamarin.com/plugins, you can actually see what they are. There are many, many community-made plugins for common API resources. Again, connectivity, taking pictures, getting location, etc. You'll be able to find just about anything you need there, and that's actually what I was kind of trying to essentially not show or what I skipped over in Visual Studio earlier. So looking at this, if we look at the references we have for like plugin.connectivity, that is one of those abstracted APIs that gives you access to all the platform's connectivity APIs, or the majority of them. So you can do things like just check if you're connected to the internet right inside of your shared library. You don't actually have to do that in your actual native or your Android or iOS projects separately. So those are very, very powerful. Again, Xamarin.com/plugins, and you'll be able to find all of those. A lot of them are actually written by James Montemagno, who actually did the slide deck as well. Yeah.
One of the things that they announced to build was that they now have the ability to embed Xamarin.Forms apps inside Xamarin native environments. Has there been any?
I don't know. I think Ed will probably cover that. Yeah. Yeah, and so that's actually it. So that's my section of the presentation. Thank you.
All right, is everybody ready for the next session? All right, so this is Xamarin.Forms. Aaron talked a little bit about it. I'm going to talk a lot more about it. My name is Ed Snider. I'm actually from the Washington, D.C. area. I live in Northern Virginia. I've been using Xamarin pretty much since Xamarin came out, so going on 5 years now or so. I've written a book about Xamarin.Forms. I really love Xamarin.Forms. I think it's awesome. I love .NET. I love the ability to do all these things that we can do with .NET now. Like Aaron said, you can pretty much use .NET to do anything these days, and it's pretty awesome. So the ability to write .NET for iPhones and Androids, really cool stuff. So we are going to jump right in here. How many of you have actually worked with Xamarin.Forms or familiar with it? Awesome. I know I recognize a lot of faces from last year and from some of the user group meetings around here, so I'm glad to see that everybody's starting to get into it. And does everybody like it? You enjoy Xamarin.Forms? Cool stuff? Yeah, it's awesome. So if you don't know or you're not familiar with Xamarin.Forms, what Xamarin.Forms is it's actually a layer that Xamarin built on top of their traditional Xamarin platform. So the stuff that Aaron talked about, the ability to use C# or F# .NET languages to write directly to the iOS and Android APIs, all that's still there. And what Xamarin.Forms is a UI layer on top of that. So he mentioned at the end there that there's specific things you have to do for each platform. You've got traditional Xamarin, the ability to use .NET to write to the iOS and Android APIs, among others. What Xamarin.Forms, and with that, you have to write specific code, specific UI code to do your UI. And the reason for that is because I think one of the beauties of Xamarin is you don't get this write once, run everywhere, magic happening that you get with other cross-platform solutions. You actually have to put effort into writing a platform-specific UI. And the awesome part about that is you get a UI that your users expect, that they're familiar with. It's got all the things that iOS does to make iOS iOS, and same with Android, things like material design and things like that. And so you want to be able to do that. However, Xamarin.Forms comes along and it gives you the ability to do that, but to do it a little bit easier. And it gives you this abstraction layer in between the traditional Xamarin and those APIs, and it gives you the ability, the single API you can write with C# or XAML to write your UI code. And what it does is it actually renders it down to the native APIs, the native UI APIs, so like UIKit, for example. And so, I guess I got a little ahead of myself on these slides. So the traditional approach, like what Aaron showed, is this. You have your shared backend. That's things like business logic that talks to the API, or a backend service. If you're doing MVVM, it's your view models. And then you have your platform-specific layers there at the top. And so that's the small percentage of code that is going to be unique to each platform. Things like UI, platform-specific APIs, such as the batteries or the connectivity, location, GPS, and all that. And then when Xamarin.Forms comes along, it kind of slides in there, and it takes a lot of that burden off of it for you, and it gives you more room for sharing code and more room for writing C# to do that. And so not only are you sharing your backend code, you're also sharing some UI code. So it does this, get through all these, here we go. Does this through a number of things. You get tons and tons of controls, layouts, things that you're probably familiar with if you've ever done Windows development, UWP, WPF, things like that. And we'll get into some of that on a couple slides ahead of here. You also get data binding. So again, if you've done WPF, you've done UWP, you know about data binding. What that is it gives you the ability to have view models in the MVVM world and bind those to your UI elements. And so as your users are doing things on the UI, it's bound to where all your logic is. And again, I'll show some of that in code as well. It also gives you a navigation abstraction. So while you can also do all your UI code, you can also do navigation, which if you think about it, that's very platform specific as well. So Xamarin.Forms gives you a single navigation API. And so if you do like push page, it's going to render down and implement, and it is implemented using the native navigation APIs on iOS, Android, and UWP. Same with animation. It comes with a dependency service and a messaging service, or a messaging center. So I guess on top of having this shared abstraction, or this shared UI abstraction layer and access to the API, the UI APIs, you're also getting almost an MVVM package. You get things that you would expect out of that, like the dependency service and the messaging center, and navigation and data binding. So if you're writing apps and you're using MVVM, you're familiar with that, you know these things, and having those included in Xamarin.Forms is even better, because it not only gives you the ability to do your UI shared, but you can also start writing pretty much a complete MVVM app all out of the box, out of the Xamarin.Forms box. So here's a look at some of the controls that you get when we're talking about the UI specifically. So on pages, some pretty obvious ones. The content page is the main one that you'll use. That's where you put content. A master detail page gives you the ability to do, depending on the device size, things like a drawer that slides out, or if you're on like an iPad, you get the way that settings are on the default iOS, so you get like a left and a right, a master detail. Navigation, it's a navigation container, so you would actually instantiate that navigation page with a content page, and it gives you the bar at the top, and it gives you access to the navigation stack. Tabbed, we'll actually see in the demo, it gives you tabs, so at the bottom you get tabs, or if you're on Android, you get the tab bar at the top, and you'll see that it's very, very native. It is native, so it's really cool. Carousel, this is actually not going to be, well, I guess it might be there, but it's being deprecated. There's in Xamarin.Forms 3.0, you'll start to get carousel as a control as opposed to a page. So in layouts, again, if you've done WPF, you've done UWP, these are all going to look pretty familiar to you, especially stack and grid and relative. Stack gives you the ability to stack elements either horizontally or vertically. Absolute is, pretty much what it says. Same with relative, the ability to arrange things relative to other things on the screen, so above, below, left, right, or to the screen itself. And then the grid is really powerful as well. The ability to do columns and rows, and then col spans and row spans, just like in WPF. The API is almost identical. And then here's a list of the controls. And there's a ton of these. I think there's 40 or more. And these are out of the box. Every one of these will have a version, or when you use these, you'll get rendered down to a platform-specific version for all the platforms that Xamarin.Forms supports. So, for example, an entry, when you put a new entry on your page in either XAML or C# on a Xamarin.Forms app, on iOS that's going to render down to a UI text field, and on Android you're going to get an edit text. And on, that might be wrong. And then on, I've been using Xamarin.Forms so much, I'm forgetting what the actual APIs are under there. On Windows, you'll get a text field or a text box. Same with all these things. And we'll look at a few of these controls like the switch, the image, the entry, the buttons, and things like that when we get into the demo. Cool thing is, on top of those controls, the ecosystem is also giving you more things like charts and calendar controls and things like that, brought to you by people like Syncfusion. And as it's been mentioned a couple times today, Syncfusion's giving all of you a free copy of the Essential Studio for Xamarin, which is really awesome. And here's some screenshots of some of the cool things that you can do with that. Super awesome. So here's a quick look. And again, we're going to do a demo, so I won't spend too much time walking through this code here because we'll walk through the code as we do it live. But you can see that a login screen, I bet you we've all written a login screen before. You know, as simple as it is, there's a lot to it. You have a couple fields, a button, and all that. But like Aaron pointed out earlier, if you're doing this traditional, like not even using Xamarin at all, you're writing this 3 different ways. When you start using traditional Xamarin, at least even if you have 3 UIs, you've centralized all your logic behind the scenes. But now you can see that just in these few lines of code, you have a login screen on 3 platforms that's using platform-specific APIs and rendering to platform-specific controls. You can also see some of the binding and things in there where the data binding is coming through. So let's go ahead and get into a demo. Any questions before or as I switch over? Good. So here's Visual Studio for Mac. We're going to fire up, actually before I get into the demo, I'll just show you kind of what it's like to start a new Xamarin.Forms project. So you can go to New Solution in Visual Studio, and then you get the File New box. And for Xamarin.Forms, you'll go into the multi-platform section, pick App, and then you get quite a few options. You can do a blank Forms app, or you can do a Forms app. And then you just kind of step through the wizard. Next, you give it a name. You can select your target platforms. I'm on a Mac right now, which means I'm not able to target UWP. If I was on the Visual Studio on the PC side, I'd be able to also target UWP to build a Windows desktop app. So we'll go ahead and cancel this, and we'll jump into the demo. Make sure I open the right one. And I will also figure out how to zoom in here in a second.
And I have a quick question.
Yes.
Are these projects and solutions files created on a Mac easily open on a Windows
Yep.
machine if I were to drop it on a USB, or Dropbox, for example?
Yeah, absolutely. Or one sec.
And then you could just go add in a UWP.
Yeah. All right, I'm back. So yeah, it uses the .sln, the solution file. It's literally the exact same. I mean, it's Visual Studio on both ends. They read that same format, and even better than Dropbox. If you use GitHub, I mean, at work all the time, we've got teams that are using Windows and Visual Studio, and then others that are using Xamarin Studio or now Visual Studio for Mac on the Mac. Totally fine.
Yeah, you set up UWP for this project, and now it's not there. It's not available, so.
Right. And that's just because I'm on the Mac, so I can't build it. But if I were to connect to this exact same project on Windows, that would light up and I'd be able to do it. But like Aaron said, you can still see the code. And since it's the Xamarin.Forms project, there's not much code in there. So what's the Nope. Don't remember my Zoom command. When you create a new Xamarin.Forms project, you get 4 projects. Right now I have 3 that are actually active since I'm on the Mac. You get a shared project or a portable class library depending on your selection there. This one's a portable class library. You also get a platform-specific project for each of the platforms you're supporting, so Android, and then iOS right here, and then UWP there at the bottom. And I'll dive into those in a minute. Really, depending on the app and the amount of customization you do, you won't go into those too much. In fact, on this project here, or on this demo app, we won't go into them hardly at all. All of our stuff is up here in the portable class library. So if you've done a lot of traditional Xamarin or any traditional Xamarin, and you've done this model where you have a portable class library and you have a couple platform-specific project libraries, those platform-specific project libraries, what those are there for is to actually build. They have the stuff that kind of bootstraps the app and it gets it going, creates the binaries, the things that you actually put on phones at the end of the day. So you still have all of that. But what you've had to do in the past is, in your portable class library, you had your view models, all of your logic and things like that, as well as probably your models and code that talks to the web services and all that. And then down here in your Android and iOS projects, you had your view piece of the MVVM architecture. And you had all your pages and your views and all that and your custom controls. Well, you'll notice I don't have that down here. Actually, my pages are or my views are in the portable class library. So if you're new to Xamarin.Forms, and you're familiar with MVVM, that might be an interesting concept for you to have your views in the portable class library. And on top of that, there's XAML. So really cool. All right, so you can kind of see, hopefully, my screen got really small when I hooked up here, but I have pretty much the MVVM pattern laid out here in the folder structure. There's the models, the views, and the view models. And we'll kind of dig into each one of these. There's also services. Yes, sir.
So if I'm going to use one of these libraries, where would it be on this project?
Typically, the way that works is the same as the plugin model that Aaron talked about. You'll get the NuGet packages, and you'll need to put those in your portable class project as well as each of your platform-specific ones. And then usually they've put something similar to how Xamarin.Forms works, where you can just access it from a single API in the portable class. So you'll code it all from the portable class library, but you have to put the libraries in each of the projects because they need to be able to get into those APIs and access and surface things for the UI.
Well, with the Syncfusion libraries, it's actually Syncfusion Xamarin.Forms environment. So
Right.
we need to also include references to those in the other projects, or just the Xamarin, or just the base Forms class library.
I don't know if I understand what you're asking.
We have to have a reference in all 3 of the projects.
For Xamarin.Forms?
That's a specific Xamarin.Forms component.
Yes. Yeah, that's what I'm saying. In specific to Syncfusion, I'm not 100% sure, but the model is generally things like that go into each of the projects. Even Xamarin.Forms, if we look at the NuGet packages here, we've got just the base Xamarin.Forms NuGet package in my portable class library. And then when I go down into iOS and I go into packages, I have still the same Xamarin.Forms core one, but then, well, I guess it's named the same thing. And then this is the iOS one, the one that's targeting iOS, and it's actually targeting the iOS APIs. And so these will work the same way. If I were to pull this NuGet package out, or any of these other plugin packages, even though I have the package in the portable class library and I'm writing all the code in the portable class library, the app wouldn't work because it needs the ties to the APIs on the platform, and that's what these platform projects get you, is access to that. So yeah, we've got our model, view model, and view folders in here. We also have a services folder. If you've done MVVM, you probably realize or know that you can hardly ever do MVVM without this third letter, so it should be MVVMS. You always need services, things that do things that like talk to the APIs, you may abstract things out into interfaces to do locations, or working with the GPS, working with the camera, things like that. Anyways, you always end up with a services folder. In this case, we have a weather service here. This demo app is going to be a weather app. If you were here last year, it's really similar to the one we did then. We'll zoom in a little bit on the code. So what this weather service does is basically just, it's responsible for going out to these openweathermap.org APIs and using some parameters such as latitude and longitude or a city string here on line 36. It pulls back a JSON response. It deserializes that JSON response into a weather object, and then we bring that weather object back into our view model, and then that's where we start data binding up to the view layer. So the main method that we're using right now, as the way the demo is so far, is this get weather one. We pass it a city, and we tell it whether or not we're using what units of temperature measurement we're using, Fahrenheit or Celsius. And then we get the weather root object. So if we go into the view model, actually let's jump into the model first. So we got a weather model here. This is, let's see, is this the weather root model? Weather root model. This is what we're getting back. So we're getting back some coordinates, some other things, the city ID, the name of the city, the date, but then we're also getting back this weather, a list of weather objects in that model. And if we go to that, which is just up here in the same file, you can see we've got the description and the icon of the weather. And so those are the types of things we'll be binding on. Now when we get into our view model, the way the view model works is we have an instance of the service here. And so you could use the dependency service for this, but right here we're just newing it straight up into the getter. Then we've got some properties. So we've got our location property. That's where the city that we want to query the weather for. We have a property, it's just a flag that says basically whether or not to use GPS. We have another one to change what format the temperature's coming back in. Then we actually have some properties for displaying the temperature and displaying the condition when they come back from the API. And then one more property, a couple more properties, one more for busy and one more for the forecast. And then there's a property that's a command, an I command. This actually comes out of the system.window.input namespace. And then Xamarin.Forms has an implementation for that I command that they call command. What a command is, if you're not familiar with sort of data binding and stuff, a command gives you the ability to bind actions. So instead of having to use click handlers, you can use a command. And the beauty of this and the reason for this is a click handler or an event handler is platform specific. And so since we're sort of up a layer, we don't really have a way, if we're writing platform agnostic code, we don't have a way to use those event handlers. We can't double click a button and get an event handler because we don't know how to use that in a portable class library. So instead, and it's also cleaner, we can write a command, we can bind that command to a button, and then it basically, the button, instead of doing a click handler, it binds the click action back to some logic in our view model. So we'll see that in a sec when I show you the view of where this binding happens. So when we actually click that button and it fires this command, this weather command, then we go into this method here, execute weather command, and this is where we use the service to pull back the weather. And then we use that weather object that we get back to also query and get the forecast. I think it's like a 10-day forecast we're getting. And then we just pull out of the weather response, we pull out the temperature and we pull out the condition. So it might say cloudy or rainy or sunny, something like that. And we put that into the condition property that I showed you higher up in the class. And that's about it. Now you may have noticed on a lot of these properties, especially the ones that have the setters, is we have this onProperty changed. In order to get data binding to work, especially data that's changing, and we're pulling it from a service and we're loading it into something, we want that to automatically pop up on the screen. We don't want the user to have to hit refresh to get data to change. So our view model inherits, or it implements, I'm sorry, I notify property changed. And again, this is something that's part of .NET more than it is Xamarin. And so you've probably used I notify property changed in other apps like UWP or Windows 8 or WPF. And when we implement this class, we go down here to the bottom and we have to create the property changed handler, and then this is the method that we're calling. And what that does is just invokes the property changed, and then the data binding and the UI and the XAML will kind of pick it up from there, and they respond to that and they say, oh, something changed, here's the new data, and it just changes on the UI. So, yes?
The property change, is it two-way? Is it two-way binding?
It can be two-way binding, it can be one-way binding, and it can be one-time binding. Those are the three options. I believe the default is two-way on Xamarin.Forms. It might be different on UWP. All right, so now if we jump into a page or a view, I finally got used to calling them pages. That's what Xamarin.Forms calls them. But in the MVVM acronym, it's a view. So if we go into the, let's start by going into the forecast view just to see some binding. So you can see here that we, when we got back our forecast, we get back a list of items. And so we're binding our list view here to that list of items. And then inside of the list view, we say for every one of those items that we got out of that collection, let's describe what it needs to look like. And that's what an item template is. And so that item template says we know we're getting back items, forecast items, and we know each forecast item has an icon, and it has a display date, and it has a temperature. So bind those here. So we're sort of moving down a layer of the data context. First, our data context was the view model. Then we associated the data context of the list view to a property in that view model, which is a collection of items. And then once we're in that collection of items and the list view is sort of iterating through those, we're now at the data context is the individual items themselves. And so that's where we're binding the display and the icon and the date. Now if we go over to weather view, it is blank. So we'll go ahead and build out some XAML, and you can kind of see. Can everybody see this okay as I'm typing? You can try to make it a little, I guess I'm maxed out. All right. So first we'll add an entry, and you can see we get IntelliSense in the XAML. So we'll add an entry, and for this we will bind to the location property in the view model. So that'll allow us to enter a location. We can enter a city like Raleigh or DC, and then so we're binding to location. If we look back at our view model, we go up here, we have, I think it was the first property on here, location, it's a string, so we bind to that. And then down here, when we call the get weather command, we grab that location, we trim off any spaces on it, and we use that to send off to the API. So that's kind of where the binding, the two-way binding out of the entry goes into the view model, and then the view model can take it and pass it off to the service. So we'll go back over here. And then we also want, we'll add a switch so that we can switch whether or not we want Fahrenheit or Celsius. So switch, I'm sorry, let's put this in a stack layout so we can put a label on it. And the orientation, we'll make this horizontal. Some autocomplete there, which is cool. And inside here, we'll do a label. Text will be use imperial question. We can adjust how what does that keep doing? Center align the text vertically there. And then we'll also add a switch. And now the switch has an is toggled property. So we can bind to that, which means every time the switch changes, its is toggled value changes from true to false, and we can bind to that, which binds to a property, a Boolean property on our view model. So we'll say is toggled. And you'll see that IntelliSense just gives us true or false, but we can ignore that and just go right in with a binding. Say it's imperial, I believe that's the name of the property. And we just close that. Now we need a button, right? Make sure I'm not missing something here. Yeah, a button. Let's add a button to call the command. This will actually take the location we've typed in, take whether or not we're using the Fahrenheit or Celsius, pass that off through the command, or use the command to pass it off to the service. So the text of our button will just say get weather. And then here's where we're binding the command that I was talking about. So just like we combine text or Boolean properties here, we're binding the actual iCommand property that I showed you in the view model. So binding get weather command. And the binding works a lot like, it's not getting the IntelliSense in there, but it works just like other XAML where you can do command parameters and things like that. So now when we get our responses back, we will display them. So let's make a label, text. We want to bind the temp. Is it temp? Is that what we called it in our view model? yes, temp, and then condition. So bind temp. We can bump the size up. You can also do custom fonts. So if the app you're building, branding specifies a custom font, you can use custom fonts in Xamarin.Forms. Obviously, we won't do all that right here, but we will change the font size, make it kind of big, make the font stand out. And then let's display the condition. All right. So now we have, oh, and one more thing. While that's loading, we don't want our user to think the app is just frozen or crashing or give up and say, I can't stand this because it's just a blank screen. So we will give them some feedback. We'll give them a spinner. So activity indicator is what it's called. And again, we want to bind to a Boolean. So we only want to show the spinner if we're actually loading something. We also want the spinner to actually spin if we're loading something. So we go back to our view model and we look at our logic and our command. Before we start anything, if is busy is already true, then that means we're already doing something and we shouldn't try to make another network call. So we'll just return out and we can hit the button again later. However, if it's false, we'll set it to true and then we'll start doing some work. So that's where we start making calls, and these are await calls and it's an async method. So we don't know how long this is going to take, so we'll just set true there, and then once it's done and it's successfully given us back something, or even if it fails and we get an exception, we need to set is busy back to false. And so what that's done is it's busy while we're doing something, and then as soon as we're done, we're not busy anymore, we turn that back to false. And so now that's a property we can bind to for things like spinners. So we know while we're actually calling the network, we're busy. So we'll say is running, and we'll bind to is busy here. And same for the visibility. We don't want just a spinner that's not spinning sitting there, so we'll also hide it if we're not busy. All right, and that's it. So now let's run this, and if I didn't mess up any XAML code, we should see an actual UI. So this will run on my iPhone 7 simulator, which is right there. I can actually bump that up a little bit now that I've got some screen real estate. All right, so we've got it defaulted to Seattle. That would be because the code, James wrote the code, and I think he lives in Seattle, so he defaulted to that. Let's see what it is where I'm from first. All right, so we'll do that. We'll hit get weather. So you see the spinner? It was only there for a second, and that works pretty fast. And then it comes back and it says 79.34 degrees Fahrenheit with broken clouds. Yes.
Can I ask you a quick question?
Yep.
I've been playing around with iOS development, and I know there's something that you have to set to keep it from
Yeah.
going all the way to the top and covering over the carrier,
Yep.
What property is that again?
Padding. You can do padding, you can do margin.
Okay.
Right, but in Xamarin.Forms, you have to do it in your control, whatever your control may be, whether it's a layout or control, add some padding, 20 pixels usually get you down.
Right, okay.
In this case, we're in a tab bar, and so we've got this navigate, or I think we're in a navigation. Let's go into the, yeah. So we're in a navigation page, so it's giving us the navigation bar, so we don't have to worry about it. But yeah, I know exactly what you're talking about. Did you have a question?
What happens when you hit the switch?
When I hit the switch, it doesn't, I guarantee you're going to say, does it update? But no, it doesn't, so we just hit that again. We could obviously bind the toggled action to a command and then have it fire the same get weather command, but for now, you toggle it and then it just does another call. It would still have to do a call anyways because you have to include the unit in the API call, but we could have wired that up. So now if we hop over to forecast and notice this beautiful tab bar down here at the bottom. Let me zoom out and slide this up so people can see in the back. That is a native iOS tab bar. It automatically supports the highlighting and everything, and the reason that it looks so good is because it actually is rendered. It's a real iOS, it's a UI tab bar coming from UI Kit. And so when we run this in Android in a minute, you'll see that it doesn't look anything like that. It looks like what you would expect on Android. And then here we have a list of some weather items, and it's the condition, looks like a every 3-hour forecast. We can bounce back and forth. That's for DC. If we were to switch this to, well, let's go back to Seattle and see how it is in there. Look at weather. It's probably a little colder there because it's still early. And there's the forecast. Oh, look, rain, 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 rain. I still love Seattle, though. All right, so let's stop that. Now, before I open up Android, thanks for that question because it reminded me to pull up this app page and show you the navigation. So how did we actually get that page? I just kind of jumped straight into this weather view XAML and I started writing stuff and we ran it. But how did we get it on the screen? And specifically, how did we get it on an iOS screen and an Android screen? So we have the page, and if we go into this app, this is sort of like the beginning of Xamarin.Forms here. This is where it all starts. There's an application subclass that you inherit from. So you implement that, or you subclass it. And then you can kind of just do some things. You can just go straight in and say main page equals new content page and put whatever you want in there. What we've done here is we've set the main page property. This is the page that's going to be on the first page you see when the app launches. So we've set it to a new navigation page. And like I said in the slides, when you new up a navigation page, you have to pass it an instance of a content page. The instance of our content page is actually a tabbed page, which obviously it's a type of content page. And that's where we've got our tabs. So you can see how simple and clean this is. To get the tab bar on 2 platforms, native UI, it's like 5 lines of code, and that's because we made the code look pretty. It could be shorter. We've got the title, we've got the context, which is our view model, and then the 2 pages right there, we just instantiate them and throw them right in as children objects, and everything just works from there. That's a lot more code, even in traditional Xamarin. Yep.
So everything you've been doing is in this PCL.
Mm-hmm.
How much stuff do you actually do in the other, the Android, the iOS, and the Windows? And what kind of code would you put there?
Yep, so good lead into the next point here. So now if we jump, so we've got this app, right? So we have an app, we need to new that up, and we actually have to do something with it, and that's how we get it onto iOS. So if we go into our iOS project, and we go into app delegate, which is where things kind of start on the iOS side, what we have to do here is first initialize Xamarin.Forms. So initialize the toolkit. We have to subclass Forms application delegate. So normally you just subclass application delegate. Xamarin.Forms toolkit has their own implementation of that, which is called Forms application delegate. So we subclass that, we initialize Xamarin.Forms, and then that gives us access to this load application method, which is a part of this base class that I mentioned. And we pass in a new instance of app, which was the one I was just showing you, where we set up the tabs, and then it takes it from there. Everything else just happens. Xamarin.Forms does its magic. And
how much of that is cookie cutter or like auto-generated?
When you do a new template, all of it. Unless you say, well, I'm pretty sure all of it, even on the blank template. But yeah, it'll kind of set everything up. And so you can literally do file new, give it a name, and then hit F5, and you'll get something that says welcome to Xamarin.Forms. Right. So you don't even have to type this code I'm showing you here. But it's good to know where it is and what to do with it if you need to change things or tweak things. And if you use maps in your app, you would initialize those here as well on the platform projects. So if we go and look at the equivalent on Android, we go into the main activity, exact same thing, except for instead of an app compat activity, it's a Forms app compat activity. That's just the Xamarin.Forms implementation of that. But we initialize it. We pass in a couple parameters, the context. If you're familiar with Android, you pretty much pass the context to everything. And then, so including that, and then the bundle. And then you just load up the same thing, a new instance of the application, and it handles everything else. So if we switch over, let me collapse some of this down here. Let's switch over to Android and see this same exact app in an Android emulator. Hopefully it uses the one I already have open. So this is just a regular Android emulator that comes with the SDK. So we'll see the same UI, but you'll notice some differences, and those are because things render differently on Android than they do on iOS. So the biggest difference you'll notice is the tab bars are up here. And do you see when I touch, I get that material design effect? That's all native. It's happening because we're rendering the tab bar down to native controls. So it's got Washington, D.C. there. We got the switch I can make this bigger, I'm sorry. There we go. So the switch is a material design switch, same with the button. It's got all that. There's the spinner. Definitely didn't look like the spinner we saw on iOS. And then there's the forecast in Celsius in Washington, D.C. Let's make sure it's still the same there. If we go over to forecast, check that out. It's all there. And you can see you kind of get those like bumper warnings. I don't know what they call that on Android, but that blue, like, hey, you're at the top of the list, or when we get to the bottom, it does the same thing. It's like, you're at the bottom. It's all there, even though all we did was just type in a XAML list view. We get the real stuff on Android, and we get the real stuff on iOS. Yep.
Question with regards to the UWP application side of things.
Yep.
Why is it that on a blank template, when you load up blank template and you hit build, it says initialize component is not found on UWP?
Let's talk about that afterwards, if you don't mind. Thanks.
It's just,
Yeah,
it's
I know
weird
what you're
to
talking
have
about.
a template with an error in it on.
Yeah, I'm sure Dan and I can both help fill you in on that. All right, so let's do a couple more things to this app. First of all, I showed you the forecast list. Now, something cool that we can do that, again, even in traditional Xamarin, you could not do it this easily. We go into the forecast view here. In our list view, let's add pull to refresh with 3 lines of code. So is pull to refresh enabled? Absolutely. And then, so that says this list now can support pull to refresh. That's all we have to do. And then we just 2 more lines of code to tell it what to do when the user pulls it and how to refresh. So we get a refresh command. So we'll bind this to the same command that the user hits when they hit the button, or that we call when the user hits the button. So binding get weather command spelled correctly. Does that have 3 M's? I can't. Yes, it did. That was all right. And then is refreshing, which is a Boolean. Now this, so when you pull, you get a spinner, and then it needs to go away when we're done refreshing. And the way that we tell it that is that we're done doing what we need to do. We're done refreshing. We're done loading data. So we'll bind to that isBusy property the same way we did on the activity spinner. The only difference is in the back you asked about the mode and the 2-way and the 1-way. So we just want to do 1-way here. We don't want the UI telling the view model that it's busy. You know what I mean? So like we only want the view model to tell the UI when it's busy and when it's done. Otherwise, when you pull, it gets crazy. So, all right, so we did that. Let's run this again here and see how that looks. So 3 lines of code, you get pull to refresh. It's pretty awesome.
That would be just about as easy to do the switch, to add in the commands for the switch to be able
Yeah.
to auto.
Yep.
Nice.
Actually, that's probably even less. It depends on how it depends if there's a toggled command. I can't remember. If not, then you have to do a behavior to wire up the event. Okay, so let's get the weather first. So we get some DC weather. And then, so here's our list. Now if I pull down, oh, look at that. There's a little Android animation for pull to refresh. So we pull it, it does a little spinning, and then it reloads. And we're good to go. Now if we change this, go back to Seattle for a sec, and we don't hit the button there, we go back to forecast. This is still DC stuff. Now if I pull, it's calling the same command, so you'll see it loads, and now it's all the rain weather from Seattle. So it's calling the same command. Now I don't have a refresh button here, so it didn't update the temperature here. Oh yes, it did, because it's 2-way binding. All right. So one more thing I want to do, just to kind of show off some of the plugins. Aaron talked a little bit about this. Plugins are awesome because they actually, Xamarin.Forms comes along and it's like, all right, you don't have to write a bunch of unique UI code anymore. We've got you covered. We built an abstraction layer. You only have to write your UI one time. Covers most cases, right? There's some custom stuff you'll always have to work around. But there was still that little teeny shim of that diagram when the Xamarin.Forms shared piece flew in the sort of the MVVM diagram. And that's because there's the other APIs, the non-UI APIs, like the battery and the GPS and network activity and things like that. Those are still platform specific. So you're still stuck with having to write potentially three types of code to do that. And the traditional way to do that, and depending on your preference, the way you might still do it is you would write an interface called like iLocation interface, and then you would put a method in there that says getLocation, and then you would write 3 implementations of that and drop them in the 3 platforms. You'd write an iOS implementation, an Android implementation, and then you would just use some sort of dependency service to get those into your view model and access them with your view model and your shared code. However, Xamarin has this model called plugins. Now, this isn't something that comes with Xamarin. It's sort of Xamarin initiated the concept and opened it up to the community, and then the community started writing these plugins. And a lot of the Xamarin components are also now being fed by plugins as well. So let's use one and just see how cool they are. If we go into the view model here, so right now we have to type in the city, and I've used a lot of weather apps and I've never had to type in the city. I mean, that's like going back to before your browser would detect your location, right? So let's do the same here. We'll detect the location. So we already have the property up here that says use GPS. So we'll bind to that in a minute in our UI, but let's get the value of that. And then if we say use GPS, we don't have to type it. So we'll say if use GPS is true, then we will, let's get the GPS. And so here's where the plugin comes in. It's a NuGet package, so we just say crosslocator.current.get position, and we'll give it 10 seconds to get our location. And that's it. So one line of code, I get our position. I didn't have to write anything, and the reason is because the plugin author already did all the work. And it's all on GitHub, it's all open source, so you can make sure that they're not doing anything crazy like login or anything like that. But the packages are coming right from NuGet, so you can see xam.plugin.geolocator, that's where it is. And like we were talking about earlier, you pull that into your PCL, and then you also pull it into each of your platform projects. So we've got it here as well. And there's a settings one. So if you recall, when we launched the app, it popped up and defaulted to Seattle. That's because it was stored it's using the local system settings. And then when we opened it up again, it remembered DC. I didn't have to go and change Seattle and change it back to DC. It's storing that. And then there's also the text-to-speech, so we'll use that as well. So these are just really cool. Go to, I think Aaron had the URL, but it's Xamarin.com, or I'm sorry, it's github.com/Xamarin/plugins. And I believe that forwards you to a different GitHub repo, but regardless, they're all there. There's a big list of them. There's hardly anything you ever have to write anymore if you're comfortable using plugins. And like I said, they're all open source. You can contribute to them and all that. All right, so we've got GPS now. Also, what am I thinking? Okay, there we go. And then now we want to get our weather using that instead. So weather root, why is it? Await, and then we'll call our weather service. Wow, batting 100 on intelligence right now. Get weather, and now we've got obviously overload. So we're using this one right now, the city. We're going to use this one. So we'll say gps.lat, gps.long, and then the units. And that's it. And we need an else. So if we didn't check that, then just use what we typed in. And that's it. Now while we're in here, might as well go ahead and say cross-text-to-speech.current.speak. And let me cheat here. Template, oh, it's easy. So just speak exactly what the results are. All right. So I just added 3 or 4 lines of code, but really, logic-wise, we added 1 line of code to speak the results from the API, the weather conditions, and then 1 line to get the location, and then we just have another line to feed that into the surface, and that's it. So now the only other thing we need to do is jump into our weather view here, and we just need to give them the user the ability to tell us whether they want to use the GPS or not. So use GPS, use GPS. That's it. Now if we run this, and I'm going to uninstall the existing one so that you can see.
And do you know if that plugin, if it handles if the GPS is turned off?
That's why I uninstalled it, so we could see the prompt.
Oh, okay.
If it's turned off, it just, I don't remember what the plugin does. I'm pretty sure it'll just give you a warning or something, or say like, hey, you need to go into settings.
Right.
I don't remember specifically, but I wanted to uninstall it so you'd at least see the system OS prompt coming into play.
Yeah.
There are 43 plugins on GitHub repository right now.
Yeah, 43 plugins. Only one with my name on it. All right, so, yes, sir. Okay, so we'll do this. So it says DC there, but we checked use GPS, so now when we hit weather, what's the name of this location, like map-wise? Okay, let's see if we get Morrisville. All right, so there's the prompt. We will allow it.
10, 81.5 degrees Fahrenheit, short pump, clear sky.
Short pump? Is that? Oh, yeah. That's where one of my clients is, and I think I hard coded the. Yeah. Yes. It's in like near Richmond, I think. All right. Let's change this to Apple. I'm embarrassed. Okay.
10, 81.5 degrees Fahrenheit, short pump.
Xamarin even reminded us in the instructions, make sure you switch this to Apple. All right, so use GPS, get weather.
10,
Okay.
81.5 degrees Fahrenheit, short pump, clear
We're going to stay in
sky.
short pump. I guess maybe I would have to restart the simulator to get the location to trigger. But anyways, it's using the GPS on there, which I have hard-coded to short pump Virginia. Now let's switch over to Android. I don't even know what Android's using. Hopefully my system will play that.
Short pump.
I know I didn't put it into the Android one. Long pump?
Maybe you should have showed him the marble one. That one.
All right, so use GPS, get weather. So same thing, we'll allow it. Stop it.
58.
Mountain View, so that's California, which is, I guess, where Google's offices are. So that's hard-coded in there somewhere. Am I missing? Oh yeah, I don't want to type in a GPS, but you can see, you can do the same thing there, right? You can hard-code a GPS. They just don't give you the nice UI like Apple does to switch it to somewhere else. All right, so stop that. I think that's all of the demo I'll show you. Any questions about the code or anything before I go back to slides? Yes?
Do we have a XAML designer? Is there any way to get to that?
Yeah, let's,
It fails when you select it.
well,
You couldn't even get IntelliSense in 2016.
let's see what we get here.
I was able to see it about half the time starting out 2017.
How's that?
I was able to see the
Oh, there we
screen
go.
about half the time.
The Android one's taking a minute to come up, but the iOS one's working.
Windows 2017.
Really?
So,
Half the time I was getting
So
errors,
Ed,
about half
do
the
you
time I was
use
actually getting
Xamarin Studio more or Visual Studio?
I pretty much spend all my time in Xamarin Studio, which is now Visual Studio for the Mac. But yeah, I do it all in here. Just because I don't know, it's preference.
So I'm confused. What's the difference between the Essential Studios for Xamarin tool that Syncfusion offers and
Visual Studio in terms of Xamarin development?
So Visual Studio is the IDE that allows you to write the code to build Xamarin apps. The thing that Syncfusion is giving you is a toolkit to add controls like the ones you see on here.
Oh, okay, it's not an actual IDE.
No.
Gotcha.
No. Yeah, the name Studio is what's
Yeah,
throwing you off.
okay.
Yeah, no, it's not ID, right. It's not a designer, by the way, it's a previewer. So as you're writing the XAML, you can just preview it, but you can't like drag things around or anything. So that's that.
So I was failing on my Windows machine. It says I need an app, it's just exe installed.
Okay. Maybe we can take a look at that in the lab this afternoon.
So it should work.
Yeah, previewers should work. I believe the previewers are out of preview, right? Yeah.
Yeah.
Okay. All right. Yeah, Dan or I can take a look in the lab after lunch and see maybe we can help fix that. All right. So now last time I was here at Xamarin Dev Days, Xamarin 2.0 had just come out and we talked a lot about some of the cool things that were happening. Now, along with that, I guess Xamarin.Forms has been open source for over a year now. I think that was news last time in the fall. But look at what's happened. The roadmap is out there. It's public. You can go to aka.ms/xfroadmap. It's a short URL, but it's very hard to say. And this is really cool. At any point, you can go in here. You can actually talk to the Xamarin team about what's going on. You can propose things. You can jump into the conversation about proposed features in the evolution forum. But most importantly, you can see what's coming up and when to expect it. Like, for example, I mentioned that the carousel view or carousel page is going to be sort of getting replaced by an actual control. And so you can see that that's going to be coming out. It'll be V1 stable will hit Q3 2017. That's calendar Q3. So probably sometime in the next couple months, you'll be able to get that. Of course, you can always switch over and get the preview bits and do it now, or play with it now.
We have a couple of apps that we've been working on that are, Xamarin based, and one of them is a wrapped web page. It's basically using the web components.
Yeah.
And the speed factor that we've seen on that is significantly lower than what I would expect from a native app. Have you had any exposure with the wrapping of web apps, or
Yep.
is it preferred? Is there a guidance as to whether or not we should wrap an app, or if we should?
I mean,
write it?
the best performance is going to be native controls and writing it. If you're in a position where you have to wrap it, that works. And like I said, we've done it. I think it just depends on the requirement. However, yeah, I mean, the interaction that you get and the performance and the usability and all that kind of stuff is just better. I mean, users would rather it be, I think, whether they know it or not, they would.
The one strange thing that I found with the wrapped app, with the wrapped website, is that in the performance, as I let it run for a while, my phone actually started getting very hot. Has there been any performance issues reported with regards to
Not that I know of.
web components?
Not that I know of. And I'm also not a Xamarin employee, so some of those types of things I wouldn't necessarily be aware of. But yeah, I've not run into my phone heating up. I mean, I have, but not because of Xamarin. It's more usually because of Waze.
Because like the other Xamarin apps that we had there, my phone worked just fine, but my phone
Yeah.
started heating up with a wrapped website, and I'm thinking, wait a minute, this is a new Samsung, so.
Yeah, no, I'm not sure about that. All right, so I got a couple more minutes here. So yeah, the community has been involved ever since they open sourced it. There's been 700 merge pull requests, 70 contributors, which is awesome. They've added a ton of new features. Bindable picker is really cool. So if you've got a list of things that you want someone to pick from, you can actually bind that to your view model as opposed to doing it statically. They've done a ton of performance things. There's some performance stuff. The focus is still on bug triage and trying to do their best to get the bugs out, because obviously new features are cool, but if the bugs are at the core, that's not good. So they've done a great job at doing that, and thanks to the community on a lot of that stuff as well. Now Xamarin.Forms 3.0 is right around the corner, and we get even more cool stuff. One of those is Xamarin.Forms embedding. What this is the ability to take a Xamarin.Forms page, a XAML page, and put it in an app that you built with traditional Xamarin, which is what Aaron showed you earlier. So if you're new to all this, you might just be like, well, I don't know what you're talking about. But if you've built a Xamarin app using traditional Xamarin, and you've got it, there's a ton of use cases for this. When I saw this at Build, the first use case I thought of was we actually have a client that has a traditional Xamarin app we've built. It's got Android built in Xamarin, and then iOS built in Xamarin, and then we've got our portable class library. Now, there's a ton of customizations going on, lots of animations and all kinds of stuff, so it makes sense that we chose that instead of Xamarin.Forms. However, there are pages on there, like the settings page, the login page, some of the help pages and stuff, that we literally wrote, and they look identical on all three of those, that if we could have just grabbed a XAML view that we wrote in Xamarin.Forms and just dropped it in there, would have saved us time. It also makes it easier to test some of that stuff and just saves time. So that's the one use case that like popped in my head right away, is why this would be really cool. The demo that David showed at Build, which was also really cool, was he had a UWP app, written with just UWP, and then he took the XAML view that was like done for a phone, and he embedded it into the desktop app as almost like a pop-up flyover thing. So there's a lot of different use cases you can use this for, but it's really neat, it's really powerful, and it's coming along. So.
Would that be similar to like the old ASP.NET ASCX component?
Like a master page?
Well, no, like the actual control, the ASCX backend.
Embedding.
Like the user control.
Oh, sort of. Yeah, I mean you get the ability to do user controls in Xamarin.Forms anyways. But yeah, it's kind of like that. I'm running out of time, but what you end up doing is you write the XAML page the same way. You don't have to change anything, and then you go into your traditional Xamarin.Forms app. You initialize Xamarin.Forms, and then you new up your content page. So say you called it loginpage.xaml or whatever. So you say new login page, and initialize it, and then you just say dot create view controller or something like that, and it returns you an actual UI view controller object, and then you can use that the rest of the way in a normal traditional Xamarin iOS way. So it's not really like embedding a control as much as it is using it to instantiate a page and then grabbing that, getting the native version of it and working with that.
Okay.
Yeah. Yep. Another cool one that they showed off at Build is this flex layout. I don't do a lot of CSS. In fact, I try to avoid it as much as possible, but if anybody's familiar with flex layout, it's pretty cool. And it's not because CSS is bad, it's just I'm bad at CSS. So for flowing things, the way this looks is kind of like that. So if you can imagine just a quick XAML thing, and you drop some elements in there, and then it's responsible for saying, oh, I'm at the edge of the screen, let me wrap around. So pretty powerful and really useful. There's been a ton of scenarios where I could have used this and had to do some other things to get this type of behavior. And then something else that's neat, new platforms, and they're platforms in the sense of where the app runs, but Xamarin.Forms refers to these as backends because they are a backend to the UI, and that's what Xamarin.Forms is, a UI toolkit. So Samsung Tizen, Mac OS, which I believe is, you have to look at the roadmap. I can't remember if that's still in preview. WPF, and then GDK, Sharp. The Samsung Tizen stuff is really awesome because now, if it wasn't cool enough that you can use .NET to write an iPhone app or something like that, you can now use .NET to write an app for your Samsung TV. It's pretty cool. And the Samsung refrigerators that have the screens on them, right now they don't have .NET on them, but eventually I believe they're getting that. So I guess you could imagine writing .NET on your refrigerator too. And then nightly builds. This, if you're really interested in playing with the new stuff, like every day you wake up and you're like, what did Xamarin.Forms do last night for me? You can subscribe to this NuGet feed, and you'll be able to get the nightly builds. I think it's a NuGet feed. Yeah. And then this is just something else they showed at Build. It's a live player, so and it's not like a simulator or anything like that. You're actually using your phone. And it's almost like the previewer that we were showing, where as you're changing your code, it's actually changing on your phone without having to recompile or anything like that. And the setup's pretty cool. I don't have it running on here because that would require preview stuff and not that risky. So yeah, you just scan a code, and then you download this app out of the App Store, the live player app, and then things just start showing up on your phone, and as you change it, like I said, it's live, it's changing, you don't have to rebuild and wait and all that stuff. So it's almost like if you're a web developer, or you used to be a web developer, and you remember what it's like to just, as you change things, the website's just changing. Like, you don't have to keep on going through this, like, 45-second build cycle and all that to see something, and then navigate through like 20 pages to get to the one page where you changed one color. It's just instant gratification for mobile developers, so that'll be really cool. So that's it for Xamarin.Forms. I think I cut into Dan's time a little bit. Hopefully he won't be too mad at me. Any questions before I leave? I'll be around obviously the rest of the day too. Yes?
Yes, in Xamarin.Forms, how do we go about doing background services? Do we have to implement it in specific
Yep.
native platforms?
Yep. Like audio or something? Like background audio or?
Background audio, HTTP requests, whatever.
Yeah.
So how do we communicate back to Xamarin.Forms if we are doing it natively in each platform?
So the best way to do it is, well, a lot of them, so HTTP is covered, it's included. You don't even have to worry about that. So like in the code I was showing, you can see it's just using HTTP client. Things, if you're doing audio, there's plugins for that that'll do it for you as well. But if you were to do it yourself, you'd have to do that interface model where you write the interface in your core, in your PCL, and then you put implementations down there, and then you inject those implementations at runtime, and then that's how you interface with it.
So how would I communicate back to Xamarin.Forms with results from the background service?
Maybe we can talk more in detail, because yeah. All right, so 15-minute break. Dan's coming up, and then when Dan's done, it's lunchtime. So it's Dan's what's between you and getting to eat. So I will let him get up here and get through his.
So thank you guys for coming out today. I am Dan Rigby. I am a Xamarin Technical Specialist at Microsoft. As you probably all well know at this point, last year Xamarin acquired Microsoft. Now that might have happened the other way around, but before the acquisition, I was what's known as a customer success engineer. But at the end of the day, I work with our customers just to make sure they can use our technologies, whether that's the Xamarin platform, whether that's something like Test Cloud, Hockey App, Azure App Services for mobile, all of it. So I'm kind of like this half engineer, half sales, chimera hybrid thing. So, I'm kind of scary, but not really. I can also relate to you. One time I was actually a consultant. So you can find me on Twitter and GitHub. And those are on at Dan Rigby. And so we're going to talk about connected and disconnected apps for mobile apps. So when you're using apps, whether that's desktop, whether it's mobile, the best apps stand out. So in your mind, I want you to think about one of your favorite apps to use on your smartphone or what else. Now, this app is probably reliable. This app is probably timely and relevant in the information that it shows you. This app probably doesn't crash. And this app is probably fast and performant, right? These are the things that we want from the apps that we build and the apps that we use, right? And now I want you to think about some of the bad experiences you've had with mobile apps, right? And that can take many different shapes, whether that's crashes, hard to navigate UI, poor performance, just not behaving the way you would expect it to, or maybe it's just slow, laggy, and the data is not available when you need it. And so we're going to kind of look at those last two pieces a bit when we talk about connected and disconnected apps. So we want our apps to be connected, so the solution is just to assume the network's always there and pull everything whenever we need it, right? Well, maybe. If you're talking about a first world Western nation like the US, internet is becoming fairly ubiquitous and connectivity. But anybody who's gotten on a subway train or gotten in an airplane or gone to the store and pulled out the Amazon app to comparison shop and found out that basically their grocery store's walls are made of lead can tell you you don't always have connectivity everywhere you go, even in a very advanced infrastructure nation like the US. And now things get even more interesting when we start thinking about other areas of the world. All of us will probably at some point end up building apps for people who are not just inside the US or Western nation. So when we look at other places, what we can see in other parts of the world, for example, is a lot of coverage in urban areas. Rural areas not doing so great. India seems to have a pretty decent amount of coverage at this point. But even this is not the full story, because this is all types of coverage. If we start just looking at 4G coverage, like LTE level coverage, it's still very sparse, right? So we need to be intelligent about how we cache data locally, how we pull data, how we use data, look at the assumptions that we make about the connectivity that we expect our users to have, right? How many people in here have actually, who work on a mobile app, have actually tested slow or intermittent connections on their mobile apps? That is great. And I'm guilty of this as well and not doing it. It is amazing how many assumptions that you think that you've basically made in your apps that basically get unraveled the moment you start dropping 10% of your packets, or suddenly requests take a second and a half to complete or more, right? So we need to make sure that we design our apps to handle all these different kinds of scenarios. They need to be fault tolerant because people just want them to work, right? So what about a backend? Well, regardless of whether you're building an app for maybe a handful of people, or you're building the next Mario Go and you might have millions of users, Pokemon Go, Mario Run. There we go. That'd be cool. Pokemon Go. All right. Mario Go. We want our infrastructure to scale and we want it to be flexible because we might have 10 users today, but maybe if we're lucky next year we might have 100,000 users or more. And we want infrastructure that can kind of grow and scale with us. So this is where Azure comes in basically, because Azure has over 100 data centers all over the world. So regardless of what region your customers are in, there's going to be a data center nearby. And as far as data centers go, this is 2 times as many as Amazon has, and this is 6 times as many as Google has. And that's not the full story either. If we think about fault tolerance and geo-regions and availability, Azure has 38 separate compute regions that are independent of one another, so that make sure we can deploy apps in a way that is fault tolerant, even if there's issues in one specific area. We have redundancy in other areas that can pick up that slack. And so we have 38 different compute regions, which is actually more than both AWS and Google combined. And so when we're talking specifically about mobile apps, we actually have a lot of options in terms of backends. In the nature of focusing on Azure, we'll look at Azure mobile apps. And so why would you use Azure mobile apps? Well, you'd use Azure mobile apps because it's very flexible, it's very powerful, and you get cross-platform SDKs. So it doesn't matter if you're writing a Cordova app, it doesn't matter if it's a Xamarin app, if it's Objective-C, if it's Swift, if it's Java, or even Kotlin. Azure mobile apps has an SDK for all of those different platforms. And from the back-end side, out of the box, you get a Node.js backend, but you can also use an ASP.NET app service as well. So if you want to replace the backend or the middleware, basically, you can do that and do it with a C# backend. On top of that, we get lots of functionality out of Azure App Service with relatively little investment from us as developers. Things like offline synchronization, push notifications, authentication, and even then we have our choice of data providers in the back end, right? So if you just took what was out of the box, you'd get an easy tables implementation using Node.js, but you could just as easily leverage SQL Azure, MongoDB, Azure Tables, and more. There's a lot of flexibility here, and we also support all the major social authentication providers as well as Azure AD in your mobile apps. We also do push notifications, and this is across a broad set of platforms. So iOS, Android, like you'd expect, but even things like the Chrome browser or Baidu-based apps in China. We support all different kinds of push notification targets. So let's build a backend. And bear with me, the first couple are in slides. Code in slides feels bad to me, but let's start. So really, there's not a whole lot to making this work. So as a Xamarin app developer, for example, we're just going to pull in a couple of NuGet packages. We're going to create our mobile service client, and all we're going to do is point it to the URL of our custom app service backend. And that's really the only basic configuration necessary. From here, it's just about working with the data. So the next thing we do, define our local SQLite database name that we're going to save on our mobile devices where we cache our data. We're going to define a table, one or more tables that we're going to store our data in, and we'll initialize it. And at that point, we're just working with local data, and we can push and pull from our backend at will when we think is relevant. So things like pulling data. It's as simple as just grabbing the synchronization context, looking at our table, and then pulling the data from the server. We can also handle conflict resolution as well. Do we want last in to win? Do we want local to win? Do we want the server to win? There's a lot of different conflict resolution scenarios there. This is cases where data is changed in two different places.
Now, when you say backend, are you referring to Web API only or WCF? I'm going to use WCF fast.
So Azure App Services today is Web API or Node.js. So it's a REST API. It's not WCF based. There's not any options today for WCF. It's just a straight REST API. But a REST API, the reason they went that way is because it can be consumed by anything. WCF gets challenging in mobile scenarios because there is, for example, you're not going to have a native iOS SDK for WCF outside of Xamarin. But I'm saying if you're building an app with Objective-C, there isn't a WCF library. So these things are built to support a broad range of scenarios and not necessarily have an opinion as to which platform you're developing your mobile apps in. Now we want to add an item. That's as simple as just taking our table, inserting the item, and then one line of code pushing that up to the server. There's really not much involved. Everything is asynchronous so that we're not blocking the UI, stalling the app or anything like that. And we can also use link to query these tables that we have locally. So this is basically a nice wrapper around a local SQLite database that we're handling synchronization to and from the backend with. And again, like I said, there's lots of different authentication providers. We can, out of the box, it's an open endpoint. You just plug in the URL and you can push and pull, no authentication, but we can easily add authentication to our backend. So that's it with my code slides. Let's actually go look at something tangible. So in the Azure portal, and I've got mine open right here. It's really easy to get started because you can basically just go to New, search for Mobile, and Quick Start. And you're going to see the mobile apps Quick Start. You hit Create, and just define a few things with subscription, which resource group, kind of the normal Azure stuff. In the interest of time, I'm not going to make you wait the about minute and a half that it takes to provision all the different resources. I've already got one set up. And so we'll just go ahead and open the one that I have set up just to take a look at it. Now out of the box, if I had just created my backend but I had no code at all, the Azure portal actually can provide us a sample app that we can download that's already connected to the backend that we just provisioned. So whether that's Objective-C, like I said, Swift, Android, Java, if it's a UWP-based app, if it's a Xamarin.Forms app, or Xamarin Android and iOS, I can just directly download a sample project that's already configured with that backend. And then I can just go from there and run it. Now I've already got a version of this app downloaded and open in Visual Studio, but I'll just open the zip file quickly so you can see it's basically the same thing. So the Xamarin.Forms template has created a Windows app, a Windows Phone app, a UWP app, an iOS app, and an Android app that are all connected to this backend that I've provisioned. Now, this sample app is very basic. It's really just a to-do app, but it demonstrates both the initialization, the synchronization, and the pushing and pulling of data from the backend. As far as the apps go, I've only added 2 NuGet packages to my app, so there's not a whole lot of setup involved here, just the Microsoft.Azure.Mobile.Client libraries from NuGet. I've defined inside my app the URL of my backend, so in this case it's mobile-quickstart.azurewebsites.net, and we can actually see that if we say existing app. It's going to give us that same information there with that URL for my endpoint. Now on top of that, I've just got a basic, this is a Xamarin.Forms app. I've just got a basic list view that displays some to-do items. So nothing fancy, just a stack layout with a grid and some strings that are rendered on the screen. I've got a view model. Anyone who's done MVVM or worked with Xamarin.Forms will seem familiar. It's just a couple of properties that we bind to the UI. Same thing for the to-do item. It's just got a name and ID and whether or not it's done, right? Now, where pretty much the majority of this logic lies is in this to-do item manager, which is, this is all the code we saw on the slides. This is the initialization of my local SQLite database. This is me pulling data from the server. This is me handling conflict resolution down here at the bottom, for example. Now in our app, we're just saying server wins. We've made a local change, but something's already, it's basically first in wins in this case. So that's a fairly simplistic way of handling conflict resolution, but there's a lot of flexibility around how you implement that in your own applications. So there's not a ton going on here, but in this template and out of the box, I've got the ability already with my backend to push and pull data. And so let us, all right, we've got my UWP app here, and just make sure I don't have a bunch of push notifications already on my device that I don't want to share. And now I've got my iOS and my Android app as well running simultaneously. So now in my case, I think I've handled this first item on the list. I think we're done with this one. So let's mark this as complete. And now I've made the change locally. And now normally you would just go ahead and synchronize it whenever is appropriate for your app. But just to kind of demonstrate the different pieces to it, I've just made this change locally in my SQLite database. If I go force a sync on either of the other two places, they're not going to see it yet. Now, specifically when I hit the sync button, we're actually going to go push that updated state on that record to the Azure backend. And so just to also showcase that, I've got my data open here in the Azure backend, and I can see. So deliver at least one bad joke during presentation. All right. Completed is false. So let me go ahead and synchronize. All right. So now we've pushed it to our backend. Now completed is now true. And if I synchronize on both my iOS and my Android app, we can see my completed item disappear. Same thing if I add a new item. There's not much. In about 15 minutes, you're going to have a cross-platform app that synchronizes data. And so that's a great foundation for you to then just build on and expand from there. And there's a lot more that you can do with the Azure App Service SDKs, right? So this is just a getting started, but it is really easy to get started. And it can scale to whatever level you need it to. Out of the box, it provisions a SQLite database on the back end just for you to test out as a developer. You also get a nice warning that I can show you right there. Please don't use this in production. Please use a real data backend like SQL Table Storage or SQL Azure. So, I mean, it's so easy to get started with these things, but it's just the tipping point, because when you think about Azure App Service for mobile, and I'll get to you in a second, and even Azure much larger, as mobile developers, there's tons of stuff here to light up different scenarios for applications. Like I said before, with push notifications, it's really easy to get started. We can do push notifications at any scale. In fact, I think you get 1 million notifications a month for free in the free tier in Azure. But we can do Chrome browser, we can do iOS, Android, Kindle devices. They're all supported. And it really takes the pain out of you trying to implement your own push notification service that has to interact with all these different endpoints. Because Apple's push notification service is different from Google's, is different from Chrome's, is different from Amazon's. They're all different. And push notification takes the pain out of that because you can abstract away but still target those platforms. What was your question?
So if you're doing this in an MVVM project, where would you put the Azure services?
So the Azure service is actually portable code. So if I go back over to Visual Studio, you're actually seeing all of this is in a shared project, but this could have easily just been a PCL. Right? So this comes down as a NuGet package that's compatible with PCLs. You still add it to your main project. There is, let's see, I'm trying to remember. I believe you do an initialization line inside your app code, and that's it. Let's see if I can find this. UWP app. funny because I'm not actually seeing it, but in the previous sample apps that I've done, there's usually a single line to initialize. But it looks like they're doing the initialization 100% in the shared code in this project. So it may not be necessary to initialize it in the app, the platform target projects. On top of push notifications, we can also synchronize just straight binary files. These could be data files, these could be images, these could be selfies for your Snapchat clone or competitor. Could be more. You can do flat files. There's a lot of things here. And same thing, conflict resolution, right? What happens when the server has a version that's different? So you change somewhere else, change locally, and we can define that conflict resolution as well, but for binary files. And we actually have a really great shopping demo app available up on GitHub at github/Microsoft/Xamarin Azure _shopping demo app. That is a mouthful, but I'm really happy to give you that URL afterward. But this thing is great. This is actually really recent. So I haven't incorporated it into my local demos yet. But this thing pulls in cognitive services. This is things like the emotion API, sentiment analysis, right? It's by the words that somebody has written, the things that they've said, their facial expression. We have services to tell you are they happy, are they sad, are they angry? There's all sorts of very interesting scenarios when you get into things like that. Like, do you have a customer service system that might take audio, feed it into sentiment analysis, and can say at the end of it, was that customer angry or happy at the end of that call? There's all sorts of different interesting scenarios that we can use this for. This sample app also uses storage, online, offline, data synchronization like before. And I will say, I was talking about that issue of not having connectivity always. A common way of handling this is to just pull everything locally, store it, cache it. So when you don't have that access to that data, the user can still open the app and interact with the stuff they pulled previously. You want to make sure that there's some functionality in your apps even when you're not fully connected. There'll be some things that you won't be able to do and you'll want to alert your user in that scenario. But what we don't want to do is an open app, get a blank screen, just like, sorry, can't connect. Try again later. That's not a good experience, and people are not likely to come back in that situation. The shopping demo app also includes push notifications, authentication, and we have documentation on how to set it up locally and try it out in your own environments. So bringing this all together, right? What we started with in the video, talking about Xamarin Platform, then talking about Xamarin.Forms. Now we're talking a little bit about backends. One of the awesome things here about C# is honestly, aside from JavaScript, there really isn't any other programming language that has the platform target reach these days of C# and JavaScript. Now, Java was there for a while, but now you can't get to an iPhone with Java, right? You can't get to a Tizen device with Java. You can't get to an Apple TV or an Apple Watch with Java. Honestly, it's a great time to be a .NET developer from this perspective, because with C# we can do wearables, we can do server, backend, web, mobile devices, embedded, IoT, and we can do it all in one programming language in basically one framework. And we can share code across all those different places. So the platform reuse strategy and story here is very, very strong, especially now with the coming .NET Standard 2.0 that'll land later this year. It's never going to have been easier to share code across all these different platforms. So the code that you write can just go that much farther in all these different environments, right? And that's powerful because we don't have to keep rewriting this stuff over and over and over every time we want to target a new device, a new platform type, etc. We can share that and we can reuse it in all the places where it's relevant. So kind of as wrapping this up, we want to plan our apps for global reach, even if today it might be a few people, but we want to have at least in our minds, make sure we're building with the right set of tools that can get us there if we need to want to go there in the future. We want to make sure we cache data locally so we can support disconnected scenarios. We kind of want to assume success and then push and pull data when we reconnect, even if we don't have it with that local cache data. And we want to make sure we select a backend and an infrastructure system to build on top of that can grow with us as our needs change over time. So that is pretty much it. Now, it would be time for lunch, except we've already eaten. If you haven't, do make sure today that you speak with Stefan, kind of share your experiences with him about your dev days. Just have a chat. The Syncfusion folks would really appreciate it. And thanks. I'm really glad you all came.